Welcome and thank you for joining us for this webinar presentation. We are the Cybersecurity and Information Systems Information Analysis Center, or CSIAC, one of 3 IAC domains in the DoD Information Analysis Centers operating under the Defense Technical Information Center, DTIC, within the Office of the Undersecretary of Defense for Research and Engineering. Our informative webinar series highlights current and emerging research and technology developments. It presents an opportunity for accelerating the DoD's leverage of these advancements by increasing awareness and fostering technical collaboration. CSIAC serves as one of the premier information research partners and curators of technology advancements and trends for the cybersecurity and information systems community. As such, our organization supports those working in the cybersecurity and information systems domain of DoD research and engineering. We do so by helping navigate the vast landscape of scientific and technical information, allowing our customers to get a head start on their technical projects. With an understanding of the cybersecurity and information systems DoD research and engineering landscape, we provide research and analysis services. We help unlock access to information, knowledge, and best practices from government, industry, and academia to stimulate innovation, foster collaboration, and eliminate redundancy. We hope you enjoyed this webinar presentation and that it serves as a catalyst for community collaboration and improved DoD cybersecurity and information systems research.
Good day, everyone. Thank you for joining us today. My name is Philip Payne. I am the technical lead for CSIAC. Before we get started, I'd like to note a couple of administrative items. First, if you are dialed in by phone and would like a copy of today's slides, they were posted to the CSIAC webinar announcement. You can go to csiac.dtic.mil/webinars and find today's webinar. When you click on it at the bottom of the announcement, it will say download presentation. Second, all participants are muted, but feel free to chat using the attendee chat window on the right-hand side of the webinar screen. You can use that to chat with each other, and I'll be monitoring that chat as well. However, if you'd like to pose a question for the Q&A session at the end, please click the 3 dots labeled More/Panel Options to bring up the Q&A window as part of your layout. At the end of the presentation, I will go over the Q&A. For the benefit of those on the phone, I will read the questions out loud to the presenter. If you have any technical issues today, please have no fear. The full presentation will be available online. Please check back to the CSI website. Once the webinar is posted, the Go to Webinar button will take you to the YouTube link. With that said, I will now introduce today's presenter. We have Joseph Matt Fryer. Matt works here on our team at CSI as a research inquiry analyst. He recently graduated from Stevenson University, acquiring a Bachelor of Science in Computer Information Systems with a specialization in software design. At Stevenson, he was a member of the Leadership Scholars Program and was an active participant in technology-related events on campus. At Service Engineering, Mr. Fryer performs in-depth research relating to technology fields such as cybersecurity and information systems. He also works with government clients to provide them with information-oriented solutions and answer their technical inquiries. Matt, it's all yours.
All right, thanks, Phil. So good afternoon, everyone. Thank you for joining us today. As Phil said, my name is Matt Fryer. I'm a research analyst for the Cybersecurity Information Systems Information Analysis Center. So today we'll be sharing a presentation that we've been working on based on our latest state-of-the-art report. So we'll be talking about extended reality, how it's being used to enhance maintenance and repair training. And specifically, we'll discuss how XR is transforming these practices, across the DoD. So quick disclaimer, CSIAC does not promote or endorse any of these companies, organizations, products, or services that we're going to discuss. So the goal here is going to be to inspire new thinking and developing awareness for these technologies. So as we go through the slides, think what you do day to day, your responsibilities, and see if this technology could be helpful in any of those areas. So before we go over the topic, I'll give a quick overview. I know the video went over a few points. So this is our org chart. So CSI, again, is one of 3 components of the DoD Information Analysis Centers, the IACs. So we serve DoD, federal government users, and they're supporting academia and industry partners. So we operate under the Defense Technical Information Center, which is DTIC, within the OUSD R&E umbrella. So these are the IAC technical focus areas. Combined, the IAC specializes in 22 distinct focus areas, and each IAC has a general field of study. These are the CSAC TFA specifically. So we focus on cybersecurity, knowledge management, and information sharing, modeling and simulation, and software and data analysis. So what we do specifically, so each IAC is made up of scientists, engineers, researchers, and information specialists, with the goal to collect, research, disseminate scientific and technical information to DoD and, again, federal government users. This is with the mission to support the warfighter by eliminating information redundancy, fostering collaboration, and just stimulating innovation across the military. These are our services and resources we provide. All of our services can be accessed and requested via our new website, which is csi.dtech.mil. So most notably on the top left is our technical inquiry services, in which we offer 4 hours of free research to anyone who submits. So for example, if you guys have a question specific to the presentation or any other technical topic, we actually invite you to submit your TI through our website, or you can email us as well. We're always happy to help. On the bottom left, you'll see that we have our state-of-the-art reports, which are in-depth publications on current and relevant topics. So as I said, today's presentation is based on the SOAR we've been working on. So SOARs provide like an in-depth analysis on current technologies and seeing the current landscape in that area. So we evaluate and synthesize the latest technical information available. The topics are identified in collaboration with the greater cybersecurity and information systems community. And we also get it vetted through DTIC to ensure there's value being added for our readers. So this presentation is an adaptation of the newest source. If you want to learn more about the topic afterwards, you can go ahead and download it via the CSI website and read the full report there. All right, well, on to today's topic. So extended reality is an all-encompassing term that groups 3 similar technologies. So you have virtual reality, augmented reality, and mixed reality. So we'll go over some key differences in between these. So quick question for the chat. So for the audience, does anyone in the audience own a VR headset or at least familiar with using one? If you have, feel free to share in the chat, and you're welcome to have a discussion while we present. So virtual reality offers a fully immersive experience by placing the user in a digital simulated environment using either headsets or goggles. This technology effectively blocks out the physical world, allowing for individuals to engage in computer-generated spaces. In a virtual setting, users can experience realistic visuals, and it can replicate real-world environments. So augmented reality, on the other hand, unlike VR, AR enhances the user's view of the physical world instead of obstructing it. So that's a key difference there. So it overlays digital information directly onto the user's surroundings. So this information can take various forms, such as images, text, or even 3D models that enrich the user's experience of the real world. Augmented reality is more commonly used than the other two, since it can be found in devices that we use every day, such as smartphones and tablets, due to their ability to display layered content. So mixed reality is actually a blend of both VR and AR. It's like a unified experience. So mixed reality allows for virtual objects to be projected onto the physical world, just like augmented reality. The key difference is that the digital elements are able to interact and respond to the real world environment. So the detection of real components and the highlighting of specific parts by the system would make it into a mixed reality system. So in 1994, Paul Milgram was a notable figure in the field, and he introduced a concept of the virtuality continuum. So this framework places the three primary areas of XR relative to the level of immersion. As you can see, on the left is the lowest level of immersion, which would be AR, and then on the right side would be VR, which would be the highest level of immersion. So any given product related to XR can be placed on the spectrum, as they can exhibit characteristics from multiple areas, and you'll see some of those examples later on. Okay, so now we have case study. So this is an older example, but it's a good one. So in 2011, there's a study conducted by the U.S. Marine Corps where mechanics tested an augmented reality headset while working on armored vehicle turrets. This was with the objective to provide visual guidance to assist with complex procedures. So the displayed elements again included text, labels, and other indicators that were overlaid on the real-world turret components. So the study found that mechanics actually performed tasks more efficiently than with traditional methods. And the user experience was described as the technology as intuitive and satisfying for the tested sequence of tasks. So the prototype success demonstrated augmented reality, its potential, and in enhancing productivity and accuracy during maintenance. So this shows the value of visual aids in reducing errors and simplifying and breaking down complex tasks. So this early XR application paved the way for further integration into the military and industrial maintenance. Okay, so what we want to convey with this presentation really is that XR is rapidly emerging technology with significant potential. And of course, it's important to recognize these new technologies and see how our own operations can benefit from them. So we believe as the sector continues to mature, XR will become increasingly vital and present in the DoD. Okay, so some advantages. So from our research, we found that XR has proven to enhance maintenance and repair procedures, informing categories. That would be streamlining education, reducing costs, minimizing risks, and saving time. So for education, XR technology is now being used in classrooms and organizations for training to supplement traditional teaching methods. So it provides improvements to the training process by reducing classroom time, classroom hours, due to its ability to provide a rich hands-on experience. So less time in the classroom and more time on the field. And XR also provides preliminary rehearsals by enabling students to train with digital assets before getting their hands on the real expensive equipment. So there's a comparative study published by the Journal of Applied Sciences from MDPI. They developed a virtual reality-based aircraft maintenance simulator in which users could immerse themselves and interact with the virtual aircraft components. So the system was designed to facilitate the safe simulation of complex tasks, which would otherwise require a lot of resources in the real world. So the developers want to implement the system into educational curriculums to enhance learning processes. So for the comparative study, they actually had two groups, both with no prior aircraft maintenance experience, and they were asked to participate. So one group was asked to take part in the VR-enabled training, while the other group was actually asked to learn via traditional methods such as video-based training. Both groups had to complete a knowledge acquisition test afterwards, as well as a knowledge retention test 10 days later. So after looking at the results from the study, it was found that the VR trainees actually retained more information than those watching the educational videos. The VR group scored higher in both the knowledge acquisition and retention tests compared to the video-based training. In terms of costs, so a major factor in any operation is cost. So the cost of traditional military training tends to be quite expensive and it requires a lot of resources to execute. So as you can see on the screen, the training costs for some qualified pilots go in the millions. And training technicians and other people in the trades can be expensive and really resource intensive. So XR technology can actually be used to reduce the costs associated with training exercises. And this is done by digitizing the costly assets that are associated with certain curriculums. So in case of the F-22 pilot, by digitizing the aircraft, that will reduce the amount of flight time required and will drastically reduce training costs. So there's another concept study done by the German Aerospace Center. Researchers found that 12% of serious aircraft accidents and 50% of engine-related flight delays and cancellations were caused because of maintenance deficits. So to help address this issue, there's a mixed reality system that was created to leverage digital aircraft components and provide users with guidance during the inspection process. So using mixed reality, the digital twin of the aircraft component could be overlaid onto the physical version, and then technicians could actually compare the two in real time. So the system included a visual interface that provided instructions during the maintenance procedures, which remained present during in the user's field of view, so they could easily access that information and increase their technical accuracy. So XR technology can significantly reduce time required for training using real-time visuals provided, such as photos, videos, step-by-step instructions. These things allow technicians to work more efficiently, streamline complex tasks. And there's actually an example from Boeing. They implemented AR for the maintenance of their planes. So each plane actually has hundreds of miles of wiring that require minimal margin of error to repair, and it actually adds like tens of thousands of hours of work annually. So Boeing's solution was to implement an augmented reality system and give it to their technicians to provide them with wiring instructions. So using augmented reality, Boeing was able to cut production time by 25%, reduce the cognitive load on technicians, and they were able to speed up their complex wiring tasks. Okay, so we talked about some of the benefits using XR technology. There's some challenges that still need to be addressed, and we'll go over those. Mainly, it's the design obstacles, the health effects, and the price. So developers that are working on the hardware are still working to create a more comfortable heads-up display for users. So there are issues with visual clarity. The headset should not only, conveniently fill the user's field of view with necessary information, but not overwhelm it. So there's a delicate balance when it comes to visual clarity. These headsets need a lot of processing power to be accurate and reliable. So powerful hardware needs to be implemented, and it needs to fit in this small headset. So that's definitely a design challenge. Uptime and connectivity are also important when developing these technologies in the field, deploying these technologies in the field, because they require a stable connection and sufficient battery life to be successful. So the Naval Research Lab was actually the first organization in the DoD to test XR equipment and determine how it can be used to enhance training programs. So the lab tackled many challenges that were presented, by XR hardware, such as graphics, depth perception, and portability. One of their main concerns and one of the challenges they mainly tackled with the wearable displays was the brightness and contrast, and being able to provide clear visuals regardless of outdoor lighting. The engineers had to make sure that the display did not emit too much light into the user's eyes, because they can damage eyesight and they can be very dangerous. So they had to make sure to balance that with the external sunlight. So interactivity with XR systems was a focus, making sure the applications had intuitive controls and the users could learn these controls efficiently. So designing user-friendly controls is critical for this technology. For the health effects, so one common challenge with this technology is the strain on the body. So after wearing the XR headset for a prolonged period of time, you might start feeling some side effects. So some health symptoms that may arise include headaches, neck pain, eye strain, motion sickness, and fatigue. And if you've ever used a heads-up before, I'm sure you've experienced at least one of these. Also, developers are still working on improving the heads-up displays and the design to reduce the health effects. But once these are dealt with more reliably, the usability of the products will improve drastically. We have a chart regarding price here with some more popular companies and products. So the recent prices of XR headsets are particularly high and can be a few $1,000s per unit. However, you can see these costs as an investment. As we talked about, the technology can streamline education, reduce operational costs, minimize risk, and save time. So when you really evaluate these, products for certain operations, the price per device can definitely be justified. Okay, so now in the following section, we're going to give some brief summaries of organizations that are impact players in XR for maintenance and repair training. So these orgs have been found to have projects, research, patents, and technology that supports the DoD in some way and exhibit the benefits of XR that we've highlighted so far. So Boeing introduced an augmented reality-based product called the Augmented Training Operations Maintenance, which is ATOM. So they tested this in an exercise in 2023 with the U.S. Air Force. ATOM provided remote support for engineers working on a C-17 aircraft. So with this technology, the experts were actually able to deliver holographic instructions to the maintenance team from over 800 miles away. So this successful trial demonstrated ATOM's potential to reduce aircraft downtime and improve mission readiness. DARPA has invested in solutions that combine augmented reality and AI to create virtual partners for military personnel. So the program was called Perceptually Enabled Task Guidance, PTG, which enables an AI assistant to deliver critical information and instructions directly into the user's field of view. So for maintenance and repair, PTG will guide engineers through complex tasks with detailed instructions and visuals to support their work. So in 2021, DARPA announced its funding opportunity for the project, allocating $40 million to create this AI-powered augmented reality tool. So other technologies incorporated into this project include deep learning, video analysis, and automated reasoning. So the agency envisions a future in where military personnel can be equipped with these AR displays and provide real-time access to critical data. DISTI provides XR software products designed for a variety of training scenarios, such as virtual maintenance training, operations training, and guided field services augmentation. So in 2020, the U.S. Army awarded DISTI a contract for the family of maintenance trainers, which involves Army vehicles. And this focused on the virtual training for fault diagnostics, troubleshooting, and repair skills. So the contract had an initial ceiling of $42.5 million. DISTI's XR solutions aim to enhance military training by emphasizing skill transfer, knowledge retention, and data-driven applications. Mass Virtual is another notable company. So in 2018, Mass Virtual was awarded a 5-year, $59 million contract to develop interactive training modules. So virtual models for aircraft and other vehicles. And this was for the U.S. Air Force's integrated technology platform. So Mass Virtual also created a wide range of VR training solutions across different industries. So for example, nuclear power plant operations, aircraft pre-flight procedures, space system operations, undersea vehicles, and aircraft engine models. So they also developed a virtual hangar, and it's a platform where designed to support the initial qualification of training for aircrew and mission support personnel. So now we have a clip of Mass Virtual's video showcasing their work.
can't be stopped. I put in the work and push the line. I'm holding my crown. I never back down. I never back down.
All right. So that was Mass Virtual. So Raytheon also has a tool. So their tool is called VirtualWorks, and it's an augmented reality tool developed by Raytheon specifically for defense training and simulation processes. So the primary use case for VirtualWorks is the remote collaboration using augmented reality, which connects users with experts, remote maintenance, technical assistance, inspections, and supplier support. So the tool provided solutions for customers by enabling remote collaboration, end-to-end augmented reality support, and maintenance of aerospace and defense repairable assets. Also, VirtualWorks can stream live video and audio between engineers and subject matter experts and connect them with other stakeholders involved in the operation. So the system was used for the maintenance of U.S. Navy ships, where it was assisted with diagnosing, repairing complex systems. There was a decommissioned Navy destroyer, and the technician on board was able to receive detailed instructions remotely from an expert through their augmented reality display. Finally, we have Tactile, and they have a software called Manifest. So Manifest is a software solution designed to improve operational workflows by ensuring jobs are done accurately. So field workers can use the software's capabilities to access maintenance data on any device, and this offers flexibility in hardware choice. So the software was built to enable experts to create augmented reality work instructions without needing to code or without needing to use computer-aided design skills. So this capability simplifies the creation of training modules using Manifest. So the DoD actually used Manifest to enhance maintenance and training operations by providing their engineers with the visual guidance of AR. So there's an example involving the U.S. Army's 5G augmented reality training program, in which they use Manifest in the maintenance of M1 Abrams tanks, which allowed mechanics to access that real-time work instructions. The U.S. Air Force also employed Manifest to train jet engine mechanics, with a study being conducted by the Air Force Institute of Technology. They were able to demonstrate how to convert routine technical orders into augmented reality content. So this was for improved operational efficiency. Engineers were found to make significantly fewer errors while using Manifest, highlighting how augmented reality can enhance these maintenance procedures. Here's a quick video on their tool. There you go. Yes. All right. If you open that black box up. Okay, so that was Manifest. Okay, so some key takeaways from the presentation. So the integration of XR technologies into maintenance and repair operations across the DoD can lead to significant benefits. XR-based training programs have changed how personnel consume training content by providing these interactive training modules that are often more effective than traditional training methods. So this has been supported by studies on how immersive learning environments can actually enhance engagement and student retention. So overall, XR technology has the potential to transform legacy processes within the DoD, which will pave the way for a future efficient, for future XR-enabled training programs. Okay, so now we can do the Q&A.
Thanks, Matt. Appreciate the presentation. Before we open the Q&A, I see the chat has been very active with some questions as well as a couple answers, which is great. I like the fact that some of our membership is actually getting a chance to actually integrate with each other. So this webinar was the result of a state-of-the-art report. I'm going to put a link in the chat to the actual state-of-the-art report if you want to read a little bit more. There is also a link in the chat for the slides as well. This webinar will be recorded, so please check back for, I saw a couple of you had some audio difficulties. Please check back for that full recording. That'll be up on the website within a day or two. So with that said, we'll now start with the Q&A. The first question was from AK. I think this was already answered, but I'll read it aloud for the benefit of the audience. And Matt, I'll give you a chance to chime in if you would like to as well. The first question was from AK. If XR reduces training costs, does it also reduce training times?
That's a great question. Based on the research we did, looking into the advantages of XR, I would say training costs and training time go hand in hand. There's multiple studies and multiple case studies in which XR was used in classrooms, and being able to engage students more with the hands-on training definitely reduced the training times, since they were able to digest the information more efficiently. Also, by digitizing the assets, having an aircraft take off, one of these Air Force's assets, that can be very expensive. So every time you have a student there taking test flights, it can cost thousands of dollars. So leveraging digital assets will definitely reduce training costs overall.
Sounds good. Thanks, Matt. The next question we have is from Anthony. He says, do we feel the creation of the digital twin maintains accuracy to the latest design changes and configurations?
That's a great question. This technology goes hand in hand with digital twins. Again, we talked about digitizing the assets. However, based on the question, it is important to make sure that the digital twin is up to date with the entire system, and that's more of the digital twin side of things. But what XR really does is, making use of these digital twins, being able to put it in either the user's field of view or in the digital environment, and enabling that training, again, by leveraging the digital asset.
Thank you. I did see a couple of the comments in there as well. Next question from Stephanie. How does XR account for lack of sensory input? For instance, a running engine produces significant noise, blowing air, and vibrations.
That's a great question. So obviously, when you do live training, that's always going to be closer to the real thing, because again, it can account for some of the sensory effects. So some of those are going to be really hard to replicate in XR, like how it actually feels, the senses, the smell, the touch. There's going to be a lot that you cannot replicate until you do the real thing. However, XR focuses on the more important aspects of the training, and provides very efficient, very cost-efficient training. Although it will lack some of those real world effects that you would encounter in the live training.
Thanks, Matt. There was also a follow-on question from Tim asking about the current state of the art in this area. One thing that we did see attending conferences and the modeling and simulation space is the combination of using other technologies in combination with XR, right? So we've come into contact with other companies focusing on haptics and things like that, and gloves that can provide sensation and touch relative to including other modalities there, right? So if you're turning a wrench, they can make that harder for you to do and things like that. XR on its own is kind of really focused on the visual aspects as well as some of the sound aspects. But that is a very good question. Appreciate that. The next one from Steve: what standalone / portable XR devices have been approved for CUI data?
That's a great question. Before you use any device and any technology really that involves CUI data, you want to make sure that the technology or the specific product is CUI compliant. In the report, that's kind of like out of the scope of what we looked into. But if you submit a TI, that'd be a great follow-up TI to this presentation, and we can certainly do that research for you and find out which XR products are actually CUI compliant.
Yeah, definitely. Matt, thanks for the commercial on our TIs and our technical inquiries. That's probably our most famous service. We do probably between 10 to 20 TIs per month. And there's no limit on the number of TIs that you can submit. So whether it's related to this presentation or anything related to our TFAs across CSI, DSI, or HDI, please do not hesitate to ask. And as well, on your way out, when you fill out the survey, if you want to see more webinars related to some of the work that we're doing here, or you want to see different topics, please fill out that survey and let us know what you would like to see moving forward. Our next question from Anthony says, is there a concern with single sourcing this training / hardware / software?
Great question. Didn't see a lot about single sourcing within our research. We certainly saw a diverse share of different products. There's a lot of companies, basically a lot of the major defense companies are all looking into this technology. Just like AI being a hot technology, I think XR is also a very contested and very important technology with a lot of potential. So you're going to see a lot of companies actually develop more technology for this. But yeah, there's definitely a diverse amount of companies and organizations working on in this field as opposed to just one single source.
Thank you. Scrolling through the chat. Next question from Don. Who in particular is doing that Abrams AR training? I'm not sure if that was Tactile, the one that you showed. I believe that's your second video, Matt.
Yes, I believe it was actually Tactile. Or actually, let's see. Yeah, so that M1 Abrams tank specifically, that project was done in collaboration with Tactile. So I believe this specific article is linked in the state of the art report. But you can also go ahead and Google it as well. But yeah, in their article, they go over how they implemented the manifest technology and working with Tactile to do the maintenance training on the M1 Abrams tanks. But yeah, that was Tactile.
Next question, somewhat related from Thomas. Was the Tactile video showing an operator doing hand gestures without a controller while wearing a VR headset?
Specifically in the video, I'm not 100% sure. I think Tactile specifically, they do support hand gestures. Obviously, different products, different technologies are going to support different controls. We talked about designing intuitive controls for the users. But yeah, I do believe Tactile, I might be mistaken, but I do believe they do support hand gestures based on the pictures and the video.
Thanks. Our next question, could you please tell me if there are any studies on the ill effects on the eyes due to prolonged use?
I can't cite one off the top of my head, but I am confident that There are some out there. I think that we included one in our state of the art report. I'm sure this is a very active field, and I'm sure there's a lot more research going on into the health effects of XR use and how to reduce them for the user. But yeah.
Yeah. Next question from Kurt. What was the definition of XR again versus AR and VR?
Oh, sure. So extended reality was the all-encompassing term. So XR is an umbrella term for virtual reality, augmented reality, and mixed reality. So XR is the big term, and then VR, AR, MR are the three smaller sections. And again, VR is the fully immersive. It puts you basically in a different world. Augmented reality adds on to the real world. So it will overlay information, but you can still see in front of you. And mixed reality is the fusion of both.
All right. Um, Next question from Felix. What is the process to initiate projects with these entities? Is the DoD helping with the cost of these projects for organizations?
That's a great question. So, when we were looking into the impact players, we looked at funding opportunities and which DoD entities are working with which organizations, and we actually saw a lot of different collaborations, right, in the impact players section. So we believe that the DoD will continue to look into funding opportunities for XR specifically, and continue to work with different companies to find the best solutions for the warfighter.
Next question from Stephanie. The presentation mentioned users can experience physical effects while using the technology. How do you counteract these effects? Is there an assumption that the students will eventually get used to it?
That's a great question. I do think that initially, to a brand new user, they're going to be a little bit overwhelmed. It is a very real surreal experience. Based on when I went to conferences and tested out some of these products, it was definitely a lot to take in. In terms of the health effects, basically to reduce the health effects, it's based on the design of the product, right? So we talked about how different organizations are looking and changing their hardware specifically to counteract these health effects. So over the years, the headaches have gotten better. The motion sickness has gotten a lot better. If you used a headset like 5 years ago, you can definitely tell the difference today that there's been strides to counteract the health effects. But the health effects are tied to the design of the product. Yeah.
All right. Our next question says, has a learning curve for the system been evaluated? And if so, on average, how long does it take to become proficient in using VR for maintenance?
That's a great question. We talked about in the presentation developing user-friendly controls. A lot of these systems are designed with technicians in mind and putting it in the hands of new users. So the learning curve is definitely accounted for. It's not terribly difficult because XR is meant to train new users, in the brand new field, and get that training to them as efficiently as possible. So it's designed for new users. So the learning curve is not too steep. It is designed for beginners and new users to get their hands on this specific product and get the train digitally, because obviously they want to focus on the actual training and not the user having to learn how to use the headset or the tablet, the handheld. They want to focus more on the actual training and the actual maintenance and repair.
All right. Our next question from Don. Do you know the name of the Army organizations that's working with Tactile for that training system? I would like to follow up with them.
Great question. Specifically, it mentions that this example with the M1 Abrams tank was done with the U.S. Army's 5G augmented reality training program. I'm not sure if they're currently active, but if you want us to facilitate that connection, I'd be happy to follow up on that and help you find the right person to talk to.
Yeah, Don, just contact us offline, and we'll definitely make that connection for you. It's not a problem. Next question from Bruce. How has aircraft design and TO data been acquired to enable VR technology? It seems like a major cost would be to acquire the data from aircraft primes to enable the technology for any aircraft platform.
Great question. This is going to be how they acquire the data is going to be different depending on project to project, product to product. We've seen a couple examples here. For example, Mass Virtual actually designing the aircraft engine digital models and designing the digital aircraft models themselves. So in that case, they produce the models in-house, whereas other technologies might rely on the other end to get their aircraft models and 3D files and such.
Sounds good. Don, you can just send an email to the contact alias, and we'll make sure to point you in the right direction. That's not a problem. Next question. Are there any calibration requirements during the maintenance of these headsets?
Great question. So each headset is going to have its own internal software, and each product is going to have its own internal software. The common practice is that each headset or tablet is going to have their own calibration process. So for example, on your iPhone, you have to set up your Face ID, you have to calibrate it, you have to show it your face. So that's a calibration process. So each device is going to have its own calibration process. It usually gives you step-by-step instructions on what to do, where to point, and what data to input to calibrate the device. And then you can use it after, and it should work correctly.
A similar follow-up questions. Do the various softwares generally work with most XR devices or specific ones?
That's a great question. So two main facets of this technology is going to be the XR hardware and the XR software. So in the presentation, we saw examples of both the XR hardware within, the price chart. But for example, there's also XR software. So for example, that'd be Tactile's Manifest. So Tactile doesn't actually produce hardware to be used with Manifest. Rather, they developed a software product, and then you install that product on your mobile device, such as a tablet or phone. So that's going to depend again by product. But yeah, the main facets would be to focus on would be the hardware and the software.
All right. I'm reading through the chat. I appreciate the subject matter experts we have they're very active in the chat. I see a lot of comments here as well. I'm only going over the questions. I'm reading those aloud as of right now, but if anybody would like a copy of the chat, we do save this off as well. So feel free to contact us and we can share that as well. Next question from Gerald, which sounds like it could be a nice follow-up TI. He says, apart from the spec sheet on page 23 of your report, I'm happy that you guys are reading the state-of-the-art report. Is there a more detailed assessment / comparison of the various XR helmet head-mounted displays?
That's a great question. Our hope with the chart was that if you were interested in a specific one, that you would go and to the specific website and research the device further. However, again, if you submit a TI to us, we'd be happy to expand on that. But for the scope of the report, we just wanted to do a high-level overview of what devices are out there.
Next question from Felix. Is it the device manufacturers or the representatives? Which ones are responsible for the repair, maintenance, and sustainment of the hardware and software?
Great question. Usually, that's gonna be the responsibility of the company. Again, it might vary from company to company. Different companies have different what's it called, licensing policies and warranties. So different companies are going to have different warranties on specific products, and that's something that they have to discuss with organizations before sharing that technology.
Perfect. I'm not seeing any more questions in the chat at this time, but I would like to thank Matt for the presentation. I would like to thank our audience for the very active chat. Like I said, if there are any questions that we couldn't answer today, please submit a technical inquiry or reach out to us directly. We'll be happy to follow up here and do some more research for you. I did see a couple of acquisition related questions in the chat. We will like to highlight the disclaimer at the very beginning of the presentation. CSI doesn't necessarily promote any of these products in and of itself, but we were happy to kind of do the research on the current state of the art within the XR world. Matt is actually going to be presenting the same presentation next week in person down at AFCEA. So we wish him good luck there. Again, the link to the slides are in the chat, as well as a link to the state of the art report itself. This will be recorded, so please check back to the CSI website within a day or so, or you could go directly to the CSI YouTube page to learn a little bit more about XR. But thanks again, Matt, and thanks everybody for joining. Hopefully we see you next month for our March webinar.
Thanks, everybody.